Welcome back, everyone. To finish off this section of the course, we're going to manually create a neural network. And what I mean by the word manual is we won't be using a framework such as TensorFlow. Instead, what we're going to be doing is trying to mimic TensorFlow ourselves by manually coding out the classes and functions needed. Doing this before we actually use the TensorFlow framework is really going to help build a nice foundation for your understanding. We're not going to build out something very complex here. It's going to be a very primitive neural network, but it should really help you for the future section when we actually show a lot of the same class names and functions used with TensorFlow. Let's go ahead and get started. We're going to start with a really brief overview of object-oriented programming and the super keyword in Python. Let's open up a new Jupyter Notebook. Alright, so let's start off with a really quick overview of object-oriented programming. Nothing too crazy here. And then we'll also show you the super keyword since we're going to be using it later on. So to create your own objects in Python, you just have the class keyword, and then you can create something like a simple class. And then inside of this, when you have functions in here, inside of a class, they're called methods. And you'll always start off with this init method, which kind of initializes the class, and then it'll always take in a self keyword. So let's go ahead and make a really simple one that just says prints hello. Okay, so there's our simple class. So if I say s is equal to the string, let's say world, I can see, hey, the type of s, it says it's some sort of string object, and if I do s dot and then hit tab here, I can see the various methods and attributes that are available for that object. So let's try this with our own object that we just created. We'll say x is equal to a simple class, and if you don't have any parentheses there, and then you type in x, it's going to say, hey, it's a simple class. If you actually want to create an instance of a simple class, you need to have these parentheses right here. So let's run this again, and then I see hello, because this init method, it executes upon a creation of an instance of this class. So it says hello. And then if I check out x, now it says, hey, simple class at, and it points to a specific point in your computer's memory saying, hey, this is actually an instance of this class, simple class, because it's not just main simple class, it's living at this part in your computer's memory. So very basics of creating a class there. Let's go ahead and delete these cells. All right, let's go ahead and add another method to our simple class. We'll say def, and we'll just have it be called yell. And yell isn't really going to do anything except print out yelling. So again, I'm going to say x is equal to a new instance of simple class, and it's going to say hello. And then when I hit x dot and hit tab, it will autocomplete yell, and then it will say yelling. So now I have my method here of this simple class. Okay, now that I have that simple class working, let's go ahead and create another class. And we'll call this extended class. You can really call it whatever you want. But the reason I'm calling it extended class is because I'm going to essentially extend or inherit from the simple class. So we'll have simple class there. And then I'm going to say def underscore underscore init underscore underscore pass in self again. And here it's just going to print out extend. So let's go ahead and say y is equal to an instance of this extended class. And now we see extend. Now notice what happened here is that we only saw extend, but even if we inherited from simple class, we didn't see hello. Now this inheritance does allow us to use methods from simple class. So even though I don't have a yell method inside of this extended class, it's only inside of simple class, this variable y, if I say y dot tab, it still has yell attached to it, and it will still say yelling. So now the question arises, how can I make this init special method also execute inside of this extended class? And the way you do that is through the super keyword. So when I call super here, it basically tells Python, hey, go grab whatever class I'm inheriting from. And then I can say dot underscore underscore init underscore underscore, close parentheses, and then run this. And now when I run extended class again, I'm going to see hello and extend, because I basically said, hey, go ahead and run the init method of this simple class, and then it prints out hello. And if this hello took in arguments, for example, if it says take an argument name, and we go ahead and concatenate that name. Run simple class again to make sure those changes are saved. Now, if I run init here, I can provide a name. Let's run that again, and then we'll say hello, Jose. Okay, so that's the very basics of just very quick overview of object-oriented programming. Hopefully you've already encountered object-oriented programming before. This is really more an overview of this super keyword than OOP. If you're totally unfamiliar with OOP, you may want to go back and check that out in a more normal Python course instead of this deep learning course. All right, coming up next, what we're going to do is discuss operations, and we're going to basically make our own operation, which is a node in a graph, and TensorFlow is also going to use this concept of a graph. So once we have that operation class that we create, we're going to create a couple of example operations, such as addition, multiplication, and matrix multiplication. Afterwards, we'll create placeholders, variables, and our own graph class, and then we'll be able to actually create a very, very simple neural network. All right, so we'll do all of that in the next lecture. Thanks, and I'll see you there.